Okay, welcome to lesson 2 of the ideal gas law. This is going to cover the ideal gas law, which is the number of molecules is the fourth variable. We've learned about pressure, temperature, and volume in the combined gas law. Now we're entering a fourth variable, number of molecules. And what do we always call number of molecules? Of course, we call that moles. So how many actual gas molecules are in there is going to play a part. The equation is PV equals nRT. Pressure times volume equals N, number of moles, R. It's an ideal gas constant. The R is always 8.31. Does it have a unit? Sure. Is it a really complicated unit? Yes. Okay, so 8.31 is a constant. It kind of deals with everything, the relationship between these other ones, okay? So your P and your V, your pressure must be in kilopascals. We had millimeters of mercury, we had atmospheres, always kilopascals. The volume can also be liters or decimeters cubed. Now, what you need to remember, okay? Remember, 1 liter equals 1 decimeter cubed. Those are the exact same amount. So in these problems, volume can be in either liters or decimeters cubed. Now, that also equals 1,000 milliliters, because we know liter is 1,000 milliliters, and 1 decimeters cubed is equal to 1,000 centimeters cubed. So the only hard thing is if you get your volume in milliliters or centimeters cubed, you got to move the decimal place three places, okay? So basically, all you have to do with this is be able to isolate and solve for any variable. It's always PV equals nRT. So in this first one, what pressure? Okay? So PV equals nRT. Because everything's on a line, if I want to isolate P by itself, I'm going to divide both sides by V. Whatever's next to what you want to isolate, that's what you divide by. So P is equal to nRT over V. Okay? So pressure is equal to N, 4.5 moles, 4.5 times R, always 8.31. That's something you have to memorize. Well, you would have had to memorize it in school. You don't have to memorize things anymore. Times the temperature. Now the temperature is 8 degrees C. But we know 8 plus 273 will give us what? 281 K. That's what we need to use. So nRT 281 divided by decimeters cubed, same thing as liters, 198. So doing that math takes it out, multiply the top, 4.5 times 8.31 times 281. Enter, divided by 198, round to 1 decimal place, 53.1. Now, what's my unit? The unit was for pressure. Pressure must be in kilopascals, kPa. All right? So, that's how you do the basic problem. Basically, you just have to be able to, what volume? So now, PV equals nRT. For what volume, I divide both sides by P. Cancels the P. Volume is equal to nRT over P. Alright? So we have this one. How many moles? Moles is N. Okay, don't forget, this has to change to K. How many moles? So now, I've got PV equals nRT. I'm going to divide everything by what's next to here. So to get this by itself, I'm going to divide by RT. that cancels. I'm going to divide this side by RT. So what I end up with is N is equal to PV over RT. So again, when you get these numbers in here, multiply across the top, divide by each one individually. So P times V, get an answer, divide by R, enter, divide by T, get an answer. All right, and that leaves us with here, we're looking for temperature. So PV equals nRT. This time we're going to get temperature by itself. So we're going to have divide by RT, cancel, PV over nR. So T is equal to PV over nR. All right? Now, one thing, last thing to remember, it asks for degree C. What you're going to get this temperature is going to come out, your answer is going to be in kelvins. So then you have to change it to degree C. So that's how to do the problem. That's how to do these. That's the big thing. Isolate and solve for any of the variables. These are answered in your notes. They're worked out in the completed notes section. So take a look. PV equals nRT. This is the easy one. We got one more to go, and that'll be lesson 3. Okay? All right. Have a great day. See you later.